In the silent, cold expanse beyond our cradle, the James Webb Space Telescope stares into the deep past, a golden eye searching for Genesis. But sometimes, the most profound discoveries are not in the distant then, but in the approaching now. It began as a whisper in the data, a faint smudge of light designated 3I Atlas, detected by ground-based surveys as it crossed the invisible threshold into our solar system. At first, it was an object of mild curiosity. Another INS, including the venerable Hubble and the all-sky surveyor Spherix, adding it to their catalogs. The initial readings suggested nothing more than a rogue comet, a harmless shard of another star's forgotten history. The plan was simple: track its trajectory, study its composition, and watch it swing past our sun before disappearing back into the void. The James Webb, with its unparalleled sensitivity, was scheduled to take a closer look once the object moved far enough from the sun's blinding glare. Then, the moment arrived. As the light interference eased, Webb's instruments locked on, and the data that streamed back to Earth was not what anyone expected. It began with a sudden, impossible spike in brightness. The object flared, its luminosity increasing by more than 400%. This was no chaotic, sputtering eruption of a comet's nucleus warming under the sun. This was smooth, controlled. The light curve, the very signature of its brightening, showed a level of stability that one scientist would later describe as utterly alien to natural physics. It looked, to the bewildered teams on the ground, far too organized. As they struggled to understand this anomaly, a second, even more disturbing feature emerged. Webb's spectrographs detected a plume of gas surrounding 3I Atlas, a cometary coma. But its chemistry was bizarre. Based on the Webb data, a staggering 95% of it was carbon dioxide. But the true shock came from the surface itself. The telescope recorded a reflective pattern shifting across the thing just beneath its surface was actively, methodically, adjusting its alignment. The processing teams, reviewing the raw frames, noted the concern, in quiet rooms and encrypted emails, was no longer whether this visitor was unusual. The question had changed. The data from one observatory after another confirmed the terrifying consistency of the readings. Its movement, its signals, its very structure. They do not conform to any known natural body. It is a thing that changes its path in a way that defies gravity alone. An object is hurtling towards us, and the most terrifying possibility is not that it is an anomaly of nature, but that it is an artifact of will. We have spent our entire existence looking out into the great darkness, listening for a signal, a sign that we are not alone. Perhaps we should have considered what we would do if something, instead of answering, simply decided to come and see for itself. From the very beginning, it was an outlier, a whisper of light that refused to conform. Some specialists, staring into the deep black, suggested its brilliant immense size, or something far smaller, shrouded in a shimmering cloud of its own dust. The idea was labeled speculative, a hypothesis that desperately needed more evidence. Yet, the observation remained a stubborn anomaly, a data point that simply could not be explained by any familiar models of interstellar traveler. As the powerful eye of the Webb telescope sharpened its focus, astronomers began to discern a breathtaking structure beneath the glare. The refined data, scrubbed and processed, revealed not a chaotic surface of rock and ice, but something else entirely. Hexagonal segments, arranged in a grid of impossible cleanliness. This was a pattern that bore no resemblance to the random, fractured geology of natural formations. According to internal notes, circulated with a growing sense of disbelief, several independent teams checked their processing algorithms again and again, hunting for the bug, the instrumental error, the phantom that had to be responsible. But the results remained stubbornly the same. The segments were too perfect, their arrangement too consistent, to be a mere accident of cosmic chance. The findings began to spread through secure scientific channels, described in hushed, excited tones as one of the most unusual surface features ever recorded on an object from beyond our own solar system. Before the global teams could even reach a consensus on the meaning of this impossible geometry, Webb detected a new signal. A repeating pulse of ultraviolet light, appearing at exact intervals of 247 seconds. The timing did not drift by even a fraction of a second. It remained precise, a perfect metronome ticking across every subsequent observation. Multiple instruments, cross-checking each other's work, confirmed the same unwavering interval. Some researchers, leaning forward into the unknown, proposed that the pulse might represent some kind of complex internal process, or perhaps a form of controlled activity. Others urged caution, their voices a steadying hand in the storm of discovery, stating that such an extraordinary idea remained entirely unverified. But even with restraint, the pulse added another profound element that did not fit the known behavior of a comet. Together, the initial spike in brightness, the controlled reflective shifts, the hexagonal grid, and the precise ultraviolet pulse formed a picture that no existing model could explain. According to the teams working around the clock on the data, the object designated 3I Atlas no longer showed the behavior of a natural body made of rock and ice. That single, stark conclusion forced every group to move beyond treating these as isolated anomalies. They had to test a new, unsettling hypothesis that all the unusual signals formed a single, coherent pattern. The established rules of comets, the comfortable certainties of celestial mechanics, no longer applied. When the early data from 3I Atlas first spread, many scientists had expected the object to eventually settle us in random, unpredictable bursts. They heat up unevenly as they approach a star, their brightness rising and falling in ways that defy precise prediction. This object, absolutely nothing about its behavior matched the natural habits of a comet tumbling through the inner solar system. The first major concern had appeared when teams studied its pat pressure of sunlight and its own drifting jets of gas. This object's trajectory, however, seemed to carry a whisper of intention. It was a silent, profound challenge to everything we thought we knew. In the vast, cold emptiness between the stars, we have always listened for a signal, for a sign that we are not alone. We expected a voice, a message we could decipher. We never expected a ghost in the machine of the universe itself. An object that moves by its own rules, shines with its own light, and pulses with a rhythm that we can measure, but cannot begin to comprehend. But Ross the Globe, simulation after simulation, built upon the bedrock of celestial mechanics, failed to replicate its journey. The algorithms that could flawlessly chart the life of a comet from birth to fiery death were utterly confounded. Teams of astrophysicists reported back with a growing sense of unease. The object, they noted, bent its trajectory in ways that, according to our understanding, made no physical sense. The change was subtle, a deviation measured in fractions of a degree, but it was clear enough to deeply trouble the most experienced researchers. It was a cosmic dancer straying from the choreography of the universe. And if its behavior was definitively technological, then perhaps it represented a threat we could not yet comprehend. As more observatories, from the high deserts of Chile to the volcanic peaks of Hawaii, turned their mirrored eyes toward the anomaly, a new and far more baffling problem emerged. Every group recorded what are known as light curves, yet none of them matched. A light curve is, in its essence, an object's signature written in light, a simple record of how its brightness changes over time. For a comet, a tumbling, outgassing body of ice and rock, his case, however, the curves disagreed in the most extreme ways imaginable. Some datasets showed 3I Atlas dimming with astonishing speed, as if something vast and unseen had deliberately blocked its light. Others, taken on the very same nights from a different vantage point on Earth, showed a smooth, steady brightening, as if the object were intentionally revealing more of its surface to the prying eyes below. Most who compared the conflicting datasets agreed the differences were far too large to be dismissed as simple measurement error. In hushed tones through encrypted channels, several individuals admitted privately that the dimming on some nights looked intentional. The brightening on others appeared almost regulated. They were quick to stress that these were wild speculations, born of frustration, yet they could not ignore the unnerving pattern taking shape. The inconsistency grew more profound with each new torrent of data. Every time a team tried to force the readings into known astronomical models, the models fractured, producing only gibberish and unexplained results. It was as if the object itself was actively shifting its physical properties between observations. Then it would simply move on, continuing its silent journey toward the next star along its path. And if it has been doing that for millennia, what else had it seen? According to unverified report bordered on heresy, was the object reacting to the act of being observed? The idea was not accepted, of course. It was dismissed as paranoia, but its very existence revealed the depth of the confusion and abiding concern. Many of them had spent their entire careers watching comets, those chaotic and gloriously unpredictable wanderers. Yet they still described the motion of 3I Atlas not as random, but as guided. They stopped short of claiming it was controlled by an intelligence, but they conceded it looked far too deliberate for comfort. As the uncertainty mounted, all attention turned to an unavoidable and fast-approaching problem. 3I Atlas was moving toward a position in the sky where our own star, the Sun, would hide it completely. For a period of weeks, it would be lost in the glare. The observers knew that once it got a strategic pause in the frantic effort to understand. Most scientists expected the interruption to be brief, uneventful, a moment to catch their breath and recalibrate. No one, in all their frantic modeling and whispered speculation, could have ever predicted that the silence itself would become the next clue. They waited for the light to return, but what they would eventually learn came not from the light, but from the darkness in between. A blackout, so absolute no telescope known as 3I Atlas, moved into its predicted conjunction. It slipped behind the glare of our own star. From our fragile vantage point on Earth, it sat too close to the Sun to be seen. This was expected. This was routine. The great observatories of the world began to lose its signature, one instrument at a time. This was only the third such object ever witnessed, a traveler from a distant, unknown star system, racing through our own cosmic backyard. For a time, It was the focus of a global scientific effort, a fleeting chance to study a piece of another world. Then, the ground-based eyes reported that the object, once a faint but definite point of light, had faded from view. Space-based instruments, our sentinels beyond the atmosphere, confirmed the problem. Within a remarkably short period, 3I Atlas simply disappeared from all routine monitoring. The loss of visibility had been calculated to the hour. What happened afterward had not been. Days bled into a week with no new optical readings. Then 1 week became 2, then 3. The object, once a point of intense focus, became a blank space across publicly available instrument feeds. A void in the data. Scientific teams that had been trading notes and jubilant discoveries now found themselves with nothing left to share. The collaborative channels fell silent, then filled with short, urgent messages. Had a signal been missed? Had a data pipeline failed? Engineers and astronomers scrambled, searching for an error in the system, a glitch in the code that could explain the silence. Nobody could find one. The complete and utter lack of reflected light was profoundly unusual. Even the faintest, most distant objects in the cosmos normally leave a trace, a whisper of photons that can be coaxed from the noise with careful processing. The teams expected at least a minimal signal from 3I Atlas, a faint ghost of its former self emerging from the sun's glare. But according to reports from several independent groups, no trace appeared. The object produced no measurable imprint in any of the optical ranges that were scoured and re-scoured. And so, the search widened. Scientists, now facing a genuine mystery, began conducting blind scans, pointing their most powerful instruments not at where the object was, but where it should have been. The great radio observatories, dishes the size of football fields, swept the coordinates, listening for any type of emission, natural or otherwise. The static of the universe, the background hiss of creation, was all that answered. The radio teams reported only noise, with no organized source. Meanwhile, infrared arrays looked for a lingering signature of heat, a faint warmth that might remain detectable even in the sun's overwhelming presence. They, too, found nothing. The readings perfectly matched the normal, cold background levels of empty space. According to internal briefings, each independent check, each new attempt, confirmed the same stark outcome: the absolute absence of any detectable signal. The missing signature triggered a cascade of debate across the research community. Speculation, once the realm of fiction, became a necessary tool. Some researchers wondered if the object's reflective surface, seen so clearly just weeks earlier, had catastrophically collapsed or changed during its passage behind the sun. Perhaps it had shed its icy mantle, leaving behind a dark, non-reflective core. Others suggested a simpler, yet equally unverifiable explanation: that the object might have rotated, its surface reorganizing in just such a way that it presented a dark face to our world. These ideas, while plausible, were labeled for what they were: pure speculation. Another, more unsettling possibility was raised by groups familiar with the profound limits of observing geometry. Perhaps the answer was not in the object itself, but in a blind spot created by the intricate dance of planets and light. A flaw not in our instruments, but in our very perspective. The static from the radio dishes continues to be monitored. The community continues to watch the sky. They are watching for a ghost. We search the heavens for answers, for companionship, for a reflection of ourselves. But the universe is under no obligation to be understood. Sometimes it presents a mystery not as a puzzle to be solved, but as a reminder of the sheer, humbling scale of the unknown. A visitor arrives from an unimaginable distance, shows itself for a moment, and then vanishes without a trace, leaving behind only questions that echo in the vast, silent dark. The initial argument was simple, almost reassuring. The blackout, they proposed, might be nothing more than a trick of celestial geometry, the object's position in direct opposition to the sun. Even our most advanced instruments, our most sensitive ears turned to the heavens, can be blinded by the glare of our own star. They can lose the thread of a story when an object slips too close to that blinding, brilliant light. But this silence was different. It stretched. It deepened. The blackout still set a record, an unnerving new benchmark in the annals of astronomy. Teams on the ground described it as the longest, most complete stretch of time without a single reliable reading from any known interstellar visitor. That fact alone elevated the situation from a technical problem to a genuine crisis. Scientists who had tracked previous wanderers from beyond our system knew that gaps in the data are an occupational hazard. Information is always lost across the vastness of space, but in this case, A's of telemetry for analysts to cling to. There was nothing. Across the global community of observers, a quiet concern began to fester, growing into a palpable dread. The focus of their meetings shifted, the conversations turning from dispassionate analysis to urgent emergency planning. What are the measurements? They asked each other. What is the critical data you would need returned the moment it clears the sun? Groups that once competed for observation time now coordinated their instruments, a global network holding its breath, preparing for the instant the object might move far enough from the solar corona to be seen again. The waiting was an agony of its own. Researchers described a potent mix of professional worry and a deeply personal impatience. In private notes, some confessed a genuine fear of what might have happened out there in the unseen furnace of the sun's proximity. Others recorded their profound frustration at the hard limits of observation, at being rendered helpless and blind during what could be the most critical period of the object's passage. The absence of data, once a mere inconvenience, had become the most troubling character in the entire drama. Without readings, speculation ran rampant, and with every passing day, confidence in a simple explanation continued to erode. Internal summaries from that period are clear. The blackout had shifted the collective mood from one of scientific curiosity to one of real, existential concern. And then, when the object they called 3I Atlas finally emerged from the fire, the very first numbers to flicker across their screens annihilated any belief that it had remained unchanged. It returned brighter, colder, and somehow more controlled. As 3I Atlas reappeared, the initial readings from the James Webb Space Telescope stopped the room cold. The telescope, a marvel of human ingenuity, recorded a surface temperature that simply did not vary with time. For a comet, for any fragment of rock and ice arcing close to a star, this is a physical impossibility. Comets are slaves to thermodynamics. They warm as they approach the sun's fury, and they cool as they retreat into the void. According to several instrument teams, the temperature of 3I Atlas remained utterly steady, a flat line within the telescope's infinitesimal limits of error. That single, impossible detail forced scientists everywhere to discard their most basic assumptions. But the object did more than just hold its temperature. It's out at back the light of our sun, changed in ways that suggested active, deliberate control over heat and light, rather than passive absorption. Analysts examining the polarization and spectral responses found patterns consistent with a surface that could adjust its own reflective properties on demand. It wasn't just passing through our system, it was adapting to it. The silence had been broken, but the voice that now spoke was one that defied the known laws of the universe. In the hushed corridors of data analysis, the initial assessments were whispered with caution. Internal notes described them as provisional, speculative, but the trend was undeniable, appearing with unnerving consistency across independent observation pipelines. The chaotic, erratic flickering of light from the object had ceased. Instead, its brightness began to rise and fall in impossibly smooth, deliberate arcs, perfectly synchronized with its slow, silent rotation. The light curve. Across multiple rotations, team after team described the changes as predictable, almost rhythmic. For those who had spent their careers staring at images of our own creations, satellites, probes, the hardware of human exploration, the pattern was eerily familiar. They pointed out, with a mixture of professional detachment and quiet astonishment, that systems engineered to manage light behave in precisely this manner. They were quick to add caveats, of course, emphasizing the comparison was purely speculative, that far more data was needed. But privately, they conceded the match was striking. As the resolution sharpened, a new layer of mystery revealed itself. Beneath the impossibly reflective surface, segmented patterns began to resolve from the digital haze. Processed frames, stacked and clarified, appeared to show distinct panels, or plates, subtly shifting into alignment. Observers, struggling for words, repeatedly used the same language in their field notes and encrypted channels. Mechanical plates, they wrote, settling into place. With every new frame, a chilling clarity emerged, a clarity that brought with it both a profound fascination and a steadily rising sense of alarm. But the most confounding piece of evidence was not what they saw, but what they did not see. There were no signs of thermal stress. If this surface had been violently reconfigured by natural forces, by internal heating or external impact, the scientists expected to see the scars, fractures, plumes of dust, the irregular degradation of a body in distress. Yet, according to the calibration teams, the surface remained pristine, intact. No fresh dust clouds, no collapsing features. The utter absence of damage only strengthened the growing, unsettling impression that whatever had moved on the surface of 3I Atlas did so with absolute control. Some analysts, grasping for a framework, settled on a working analogy to our own spacecraft hardware. The behavior, they argued, resembled the adjustable panels used on human craft to manage sunlight and heat. Panels that tilt and reorient to maintain equilibrium. While this analogy was officially labeled as speculative, a necessary caution against a leap of logic, several independent groups flagged the similarity in their written summaries. And so, the attempts to anchor this object in the realm of the natural began to falter. Computational models that invoked GIS changes, but they failed to account for the whole picture: the steady temperature, the consistently aligned segments, and above all, the repeatable, clockwork arcs of light tied to its rotation. Natural jets are, by their very nature, chaotic. They erupt, they fade, they are unpredictable. They cannot produce long-term, regulated reflectivity across an entire surface. According to multiple independent teams, the sheer combination of observations was systematically dismantling every plausible natural explanation. It was a process of elimination where, one by one, the familiar possibilities were being crossed off the list. With every new photon collected, with every sharpened image, this interstellar visitor moved further and further from any known category of celestial object. It was becoming something else entirely. Something that forces us to reconsider not just what might be out there, but the very definitions we use to understand our universe. A quiet disquiet began to ripple through the world's observatories. It was a tension that existed not in the public summaries, but in the margins of notebooks, in the late-night correspondence between colleagues. In private, some of the finest minds in astrophysics admitted to a feeling that bordered on fear. Others vented a raw frustration, an anger directed not at each other, but at the elegant, trusted models of celestial mechanics that were now failing them so profoundly. Publicly, the consensus remained a carefully constructed fortress of caution. Reports were filled with hedging language, labeling the mounting evidence as speculative, and calling for yet more verification. But the next wave of data would obliterate that fortress. It would tear down the last comforting assumption that the object designated 3 Elatlis was merely an anomaly, a 1 in a billion cosmic fluke. As the telescopes once again found their focus, the returning flood of clear observations revealed a single, impossible detail. A detail that sent a tremor of disbelief through every research team on the planet. 3. Eatlas had begun to vent. A single cohesive jet of gas was emanating from its surface. At first, this was met with a flicker of relief. This is what comets do. Warmed by the sun, their frozen interiors turned to gas and burst forth in spectacular plumes. It was expected. It was normal. But that relief collapsed in a matter of hours. Because the plume was pointing the wrong way. Instead of trailing behind the object, a ghostly tail pushed away by the solar wind, this jet was aimed with unnerving precision, directly toward the sun. It was a flagrant violation of cosmic law. Comet tails are a simple matter of physics. The constant pressure of sunlight and charged particles pushes gas and dust outward, always away from their source of heat and light. This plume did the opposite. It flew into the stellar wind, not with it. According to multiple internal memos, researchers ran diagnostics on their instruments again and again. There had to be an error, a sensor artifact, a glitch in the software, because no known natural force in the entire solar system could produce this effect. But confirmation began to pour in from independent observatories. The Hubble Space Telescope, orbiting high above the distortions of Earth's atmosphere, recorded the same defiant, inward-pointing plume. The KEK Observatory in Japan confirmed it. A consortium of European observatories, viewing from entirely different angles, reported the exact same result. Each team saw the same phenomenon: a thin, steady line of material holding its form, aiming into the glare of the sun, instead of fleeing from it. The verdict, returned from every corner of the globe, was unanimous. The error was not in the instruments, but in our assumptions. A deeper analysis only deepened the mystery. The P steady over long periods. Natural jets from comets are chaotic affairs. They scatter, they wobble, they break apart into uneven clouds as the nucleus tumbles and rotates. None of that was happening here. This plume maintained a concentrated, disciplined form that had no parallel in the celestial record. Scientists scrambled, testing every explanation familiar to them. Could some bizarre magnetic field interaction be responsible? No, the models showed it was impossible. Could the object's rotation be forcing the material forward? No, that would create a spiral, not a straight line. The process of sublimation, the simple act of ice turning to gas that drives all comet activity, could not create such a focused stream, let alone one that actively fought against the sun's radiative pressure. A comet that shouldn't exist, that had lost its tail, that had defied physics and grown brighter when it should have gone dark, had now presented its most unsettling feature. And then, as analysts cross-referenced the plume's activity with the object's precise movements, the most alarming pattern of all emerged. Each time the plume strengthened, 3I Atlas altered its trajectory. The change was infinitesimal, a nudge measured in fractions of a degree, but it was measurable, it was consistent, and it was unambiguous. The plume was not a passive trail of gas being shed into the void. It was an engine. We had spent generations listening for a whisper from the stars, a faint signal buried in the cosmic noise. We never imagined the first reply would not be a sound, but a quiet, deliberate act of defiance against the very laws that govern our universe. It began with a signal, a structured, rhythmic pulse from the cold, silent depths of interstellar space, aimed with unnerving precision directly at planet Earth. The source was a mystery, a traveler from beyond our sun's embrace, designated 3I Atlas. It was only the third object ever confirmed to have journeyed from another star system, a rare and precious messenger from the void. But this messenger was behaving strangely. Analysts tracking its trajectory noted anomalies that defied simple explanation. Its path through our solar system was not the smooth, predictable arc of a celestial body governed by gravity alone. There were subtle yet distinct changes in its motion. These shifts coincided perfectly with visible plume bursts erupting from its surface. The official explanation, the cautious one, was outgassing. Ice vaporizing under the sun's warmth, creating a natural form of propulsion. But even in those early reports, a seed of doubt was planted. Analysts stressed the speculative nature of their thoughts, yet they could not ignore the data. The motion looked disturbingly similar to the controlled thrusts of a spacecraft. As sharper images arrived from our most powerful observatories, that doubt began to fester. Propulsion specialists, the scientists who study the intricate dance of engines and orbits, raised more urgent concerns. The pattern of movement, the sequence of the bursts, and the corresponding course correlated engine burns. These were the kinds of minute adjustments our own probes used to fine-tune their approach to a distant planet. These observations appeared in private notes and the early drafts of internal reports, often flagged as unverified. Yet team after team acknowledged that the evidence, however unsettling, pointed towards some form of guidance. The reaction across the scientific community began to change, moving from academic curiosity to a quiet, spreading alarm. Until this point, 3I Atlas was considered unusual, certainly, but still within the vast, forgiving range of natural phenomena. The inward-pointing plume and the controlled shifts in its movement shattered that comfortable view. If something can adjust its direction deliberately, then it can choose its destination. It is no longer just a visitor. It is an arrival. Some researchers would later describe this period as the moment 3I Atlas stopped being a scientific curiosity and became a potential vector of unknown intent. Others expressed a deep frustration at how far the data had strayed from accepted models, as if the universe had suddenly decided to break its own rules. In shared summaries circulated through secure research networks, one phrase appeared again and again: a clear turning point. 3I Atlas something built with purpose. This revelation forced investigators to dig deeper. They turned to spectral analysis, using the Webb Telescope to dissect the light reflecting from the object's surface, a method that reveals its fundamental composition. The first results only intensified the mystery. Webb detected a nickel-iron contaminated, blended with countless impurities from their violent formation. The alloy on 3I Atlas, however, appeared unusually pure. According to multiple analysis teams, the readings suggested a level of refinement that natural processes simply do not produce. It suggested metallurgy. It suggested manufacturing. When this finding was cross-referenced with earlier data hinting at a hollow interior and an engineered shell, the implication became inescapable. We had spent centuries gazing up at the stars, listening for a whisper in the static, wondering if we were alone in the immense, silent dark. We searched for a message in a bottle thrown across the cosmic ocean, but we never truly considered that the message might be the bottle itself, a silent, purposeful vessel crossing the unimaginable gulf between worlds, its course corrected by an unseen hand. The great, quiet expanse we had studied for so long was no longer just a passive void. It was an ocean, and something was finally sailing our way. A deep sense of caution permeated the initial reports, a professional insistence that every finding required scrupulous verification before any conclusion could be dared cascade in. The object's spectrum, its chemical fingerprint, unveiled something that defied explanation. Cyanide compounds, not drifting as a vaporous halo, but built directly into the surface itself. In the known lexicon of comet chemistry, this was heresy. Cyanide is a ghost, a transient gas that should appear only when a comet warms near a star, escaping its icy prison. But here, the compounds were not a fleeting vapor. They were integral, fused into the very structure of the object, as if they were a component of its construction. Specialists in cometary composition, their statements couched in the careful language of preliminary findings, noted that this pattern matched no known natural behavior. The difference from the norm, they admitted, was stark. To probe deeper, teams turned their instruments to the very light glancing off its enigmatic surface. And as they analyzed the way this light behaved upon impact, a far more radical possibility began to surface. Certain wavelengths returned a signature, an echo, that spoke of open space just beneath the crust. This is a behavior seen not in solid rock and ice, but in hollow structures. In an almost unbelievable coincidence, it turns out that the two primary directions from which the famous "wow" signal originated and the trajectory of this interstellar visitor are perfectly aligned. Several independent teams recorded the same baffling result, stating that it hinted at internal chambers rather than a solid, monolithic interior. They emphasized, of course, that the idea was speculative, that such patterns could have multiple causes, but the readings were unnervingly consistent across every observation. The mass measurements only added to the growing confusion. When analysts compared the object's vast volume with its estimated mass, they found a mismatch so profound it could not be explained away by any conventional mixture of ice and rock. The object was impossibly light for its immense size. According to reports from gravitational modeling groups, the numbers didn't just hint at hollowness, they seemed to demand it. Their models supported an interior that was mostly empty space. This result created a palpable tension within the scientific community, a direct conflict with every established expectation for an interstellar wanderer. Suddenly, earlier observations took on a new, almost unsettling relevance. The strange pulses of brightness, once dismissed as mere reflections from an uneven surface, now seemed to paint a picture of light. Bouncing within an open shell. The timing, the peculiar cadence of the pulses, matched the physics of light ricocheting through empty space. Some researchers began to whisper that this suggested internal gaps, voids large enough for light to travel, unimpeded, from one interior wall to another. The idea remained officially marked as speculation, but it appeared with increasing frequency in their internal discussions. The final piece of the spectral puzzle was perhaps the most profound. Rare absorption lines, signatures buried deep in the data, hinted at layered materials. But these were not the chaotic, jumbled layers of natural accretion. The analysts who painstakingly reviewed the lines described the arrangement as structured, organized. They spoke of a possible sign of construction, rather than the random layering of cosmic debris, all while stressing that absolute confirmation was needed. As the object continues its silent journey, its path will carry it past even more of our robotic explorers, silent sentinels waiting in the dark. We have sent our questions out into the void, and now, it seems, a reply is tumbling end over end back through our own solar system, waiting for us to find the courage to read it. The surfaces of natural bodies are never perfect. As they tumble through the void, they shift, they warp, they betray the subtle imperfections of their creation. But here, the data remained impossibly consistent. According to the analysis of several independent teams, this profound stability pointed not to a natural origin, but to a controlled, unnervingly uniform outer surface. It was a stillness that screamed of artifice. Piece by agonizing piece, the evidence began to assemble itself into a single, terrifying picture. For the growing number of researchers who reviewed the telemetry, the object designated 3I Atlas no longer resembled the random debris of a cosmic collision. It showed signs of deliberate construction, of a purpose that remained stubbornly silent. This radical view, while unverified in any official capacity, continued to gain a quiet, urgent support in the hushed corridors of astronomy. But the most profound shock was yet to come. The James Webb Telescope, our most powerful eye on the cosmos, detected something else. Something far beyond 3I Atlas. Another object, approaching from the silent depths of interstellar space. Just as Webb registered this second anomaly, 3I Atlas, as if in response, transmitted its final cryptic signal. After weeks of intense focus on the primary object, teams were compelled to perform a kind of digital archaeology. They re-examined deep archive scans from the telescope, hunting for ghosts in the data. And there, hiding at the very edge of detection, they found it. Webb had recorded a faint mass, a whisper of a signature far beyond the orbit of Neptune, on a trajectory that matched no previously cataloged body in the solar system. The signal had been weak at first, a statistical ghost in the machine, but it was undeniably real. Analysts, reprocessing the raw images with new parameters, flagged it as both unmistakable and deeply concerning. The timing triggered immediate and widespread alarm. The final ultraviolet pulses recorded from 3I Atlas before it vanished aligned with a chilling precision to the incoming object's path. These pulses, once dismissed as odd periodic noise, were now reevaluated. Internal reports confirmed that cross-checks showed the rhythmic flashes matched the distant body's approach vector, as if they were not noise at all, but a set of coordinates, a beacon, a summons. Several teams described the mathematical match as too exact to be a coincidence, though they carefully framed that conclusion as provisional, subject to further, desperate verification. When viewed in infrared bands, it seemed to actively avoid reflection in the specific wavelengths most telescopes use to find faint, distant bodies. The world's most powerful observatories were now hunting for answers to a question that was keeping astronomers awake across the globe. Observers described it as fundamentally cold and deliberately non-reflective, a patch of absolute blackness moving against the faint light of the cosmos. Some analysts began to suggest, in speculative notes that circulated widely through private channels, that this lack of a signature was not a natural property. It was a tactic, an active measure to remain unseen. As the faint signature slowly strengthened with its approach, the object began to adjust its course in small but precisely measurable ways. Trajectory updates revealed subtle, calculated changes that coincided perfectly with the last known pulses from 3I Atlas. It was not drifting, it was navigating. It was responding. The silence from the stars had finally been broken, not by a greeting, but by a rendezvous. We had spent a century listening for a whisper from the universe, never once considering that the first voice we heard would not be speaking to us. For observatories across the globe, the pattern was unmistakable and deeply unsettling. The motion of the object designated 3I Atlas looked responsive, almost deliberate. The data suggested a whisper across the void, a locator signal sent from the departing visitor, and in the cold, silent dark, something vast had reacted. This terrifying gent cross-checks at multiple observatories. And once that undeniable link was forged, the entire narrative shifted. Among the world's leading science groups, the conversation changed. Researchers began treating 3I Atlas, this third-ever interstellar object, not as a lone visitor, but as a forward probe. Early internal summaries were couched in guarded language, yet their meaning was plain. They described a scout that had meticulously mapped our system, transmitted its findings, and then departed. While public-facing documents remained speculative, the consensus inside these closed networks hardened with astonishing speed. The implications were immediate and chilling. If 3I Atlas had been an active scout, then the incoming body could only be part of a larger mission, or a fleet. The entire paradigm shifted from anomaly hunting to threat assessment. Scientists who had once been cautious about speculation now spoke with a raw urgency about the need for coordination across agencies, across nations. For many, the greatest shock was not the alien nature of the probe itself. It was the sudden, terrifying arrival of something far larger that appeared to be answering its call. As the second object closes the distance, we are left to confront a future for which no observatory, no government, was ever prepared. We spent a century listening for a sign of life in the universe, never truly considering what we would do if the silence was finally broken.